Hello friends, now we are going to discuss about variable valency. In the previous video, we have done the video on valency, right? So variable valency, what is it means? Variable, like one or more other, like you see one numbers in maths also you are seeing now. So variable valency. For example, you take metal atoms. What we know about the metals? Metals are electropositive, right? And metals have valence electrons 1, 2 or 3. The same way, here when you are considering to the metals, some metals, especially D block elements, okay, D block elements will have a variable valency. D block elements we can say group 3 to 12 in the periodic table, and they are located in the middle of the periodic table. So now here D block elements you take, for example, iron is there. Iron is having a variable valency 2 and 3. Copper 1 and 2. Silver 1 and 2. Gold 1 and 3. And even tin 2 and 4. 2 and 4. Okay. So like here what we discussed about the valency, the number of, like valency in the sense combining capacity of an element, right? And the another one, according to the new concept, what we discussed, addition of one hydrogen atom, one chlorine atom or double the number of oxygen atoms, right? No, like one hydrogen or one chlorine or double the number of oxygen atoms. This is what we have discussed about the valency definition. And even along with that we discussed one more also, sharing of electrons, gaining of electrons or losing of electrons. That also comes under valency. So now here you see, just I will show you with the chlorine atoms. Here 2 and 3. So FeCl2, ferrous chloride, and FeCl3, ferric chloride, like this. And even copper, CuCl or CuCl2. Okay. So like this, 1 and 2. See here 2 chlorine atoms are joined with the iron atom, and here 3 chlorine atoms are joined. So 2 and 3 are the variable valencies of iron. So 1 and 2 here, 1 chlorine atom and here 2 chlorine atoms. Atomicity of chlorine is 2. Next you take a silver atom, AgCl, AgCl2. Okay, so here also silver will get the 1 and 2 variable valency, and Rm you take AuCl, Aurous chloride, auric chloride, AuCl3, auric chloride. It's the same thing, SnCl2, stannous chloride and stannic chloride, etc. Like this we can say, like all the D block elements will have the variable valency. For example, here 2 and 3 we are seeing now. In case of metals, if we are considering, in case of metals are having a more than one valency, that is a variable valency. So here metals you take here, if lower valency we are taking that, we are calling it as a OUS, lower valency we are considering it as a OUS, and higher valency we are saying it as a IC form in the last higher valency IC. For example, you take here FeCl2. Okay, name of the compound we will write it here as FeCl2, ferrous chloride, which is the lower valency here. Iron is having a variable valency 2 and 3, right? In this, which is the lower one? 2 is a lower. So OUS we wrote here. So ferrous chloride. The same thing. Next, what is the higher valency here? 3. So FeCl3. Okay. So here we will say ferric chloride. Ferric chloride means FeCl3. Okay. So here again higher valency. The same thing. Here tin we will write here. Stannous chloride. That is a lower valency. And stannic chloride, we will say that as a higher valency, stannic chloride. Okay, so like this we can able to explain about the valency. Even mercury also we can say, mercury having a variable valency 1 and 2. Okay, mercury chloride, HgCl2. That we are telling as hydrogenous chloride. Hydrogenous chloride. This is lower valency HgCl when you are writing hydrogenous chloride, and you take a HgCl2. HgCl2. This is hydrogic chloride. Hydrogic chloride. So now you see here also IC, higher valency. IC, OUS is the lower valency. So based on this, metals will have OUS in the sense lower valency will consider of the chlorine atom in case of that, and higher valency will consider with IC. So like this we can say the metals. And then what about the non-metals? Is there any variable valency of non-metals? Yes, we have a variable valency of non-metals, especially only two non-metallic elements. Non-metals usually will have 4, 5, 6 or 7 valence electrons, and when it is coming to the valency we will find there 8 minus 5, 8 minus 6, 8 minus 7, 8 minus 8, like that. 3, 2, 1, 0 we will say the valencies. So here when you are coming to the non-metallic variable valencies, only two non-metals, the two solid non-metals of phosphorus and sulfur, we have variable valency. Phosphorus and sulfur only we have variable valency. These two are the solid non-metals. So now you take phosphorus. What is the atomic number of phosphorus? Z is equal to 15, right? So write the electronic configuration. 1s2 first shell, second shell 2s2 2p6 8, third shell 3s2 3p3, right? 3s2 3p3. So first shell, second shell, third shell. Which is the valency shell here? Third shell is the valency shell. So I am writing here as a diagrammatic representation of this. Okay, electron should be with anti-parallel spins. So here 3s2 third shell, and next when it is coming to the p orbital, 1, 2, 3 suborbitals, px, py and pz suborbitals are there. So 3 electrons only here, no? So 1, 2, 3, right? So here this is called ground state configuration. This is called ground state configuration. So in this ground state configuration, this is third shell, right? 3p3 is there here. So third shell according to our shells and subshells configuration. Here we have another one, d orbital also, no? So d orbital 5 are there, 5 suborbitals. Okay. So here 3d 0 will be. Okay. 3d will be 0. So when you are giving energy to the electron, what will happen? At the excited state, that is what here we can say. You are eating now, after eating food, how you will be? Very active, right? You are not eating food means you won't be active. Like your normal state only will be there. So the same thing when you are giving energy to the electron, that excitation is happening. This electron will jump towards this. Okay. So now we can write here. So s orbital 1 electron and p orbitals already 3 are there. 1, 2, 3. Right? And when it is coming to the d orbital, so 1, 2, 3, 4, 5. So here the s orbital electron only will jump here, right? So here one electron will come. Okay. So here we can write it excited configuration 3s1, 3p3 and 3d1. Right? So here this we are calling unpaired electron. This we are calling unpaired electron. And this we are calling paired electrons. Paired electrons are electron pair also we can say here. Right? So electron pair. Okay. So when you are considering this one, here, you see here, how many free electrons are there? 1, 2, 3, 4 and 5. So, 5 free electrons are here. 5 free electrons are here. So, that is the reason. Phosphorus already we know, we have an idea that it is belongs to 5th A group element. So, 8 minus 5 is equal to 3 valency. This is normal valency, right? And based on this excitation, phosphorus will get another valency also. That is 5. Okay, 5. That is a 5 valency because of unpaired electrons. So for example, take PCl3, phosphorus trichloride, PCl5, okay, phosphorus pentachloride. Even nitrogen also we can take like that at the excited level. Okay, so PCl3, PCl5. So this is about the phosphorus variable valency. Then what about the sulfur? Sulfur, I said no here. Sulfur, the second non-metallic, solid non-metallic element. This is compared to next element only. Just a successive element only for the phosphorus. Okay. So now we will explain how that will come. How sulfur is going to get variable valency. So now you see here sulfur atomic number is 16, right? So configuration will write 1s2, 2s2, 2p6, 3s2, 3p4. Correct, no? So 2 plus 2, 4, 10, 12, 16. Which is the valency shell K, L, M, right? So valency shell configuration you take here. 3s2, 1 and 2 electrons. This is 3s2. At the ground state, this one. At the ground state configuration. Okay. So now 3p, how many electrons are there? 4 electrons. 1. So here px 2, py 1 and pz also 1. Okay. So according to electronic configuration, 1, 1, 1 should fill with the first. If extra is there, we have to keep it as a pair. And 3d will be as usual, we know, we discuss now 1, 2, 3, 4, 5. So here 3d will be 0. Okay. So the paired electron is there, right? At the excitation, what will happen? First excited state. Okay. First excited state. This electron of px2 will jump to this. Okay. So now I will write as usual this as this one. And the next one, it is coming to this 1, 2, 3. So one single electron. This electron is jumping into the 3D. Okay. So 1, 2, 3, 4, 5. So this is coming here. That is the reason we can write here as a 3s2, 3p, 3 and 3d, 1. So here in the d orbital and p orbital, how many free electrons are there? 3 plus 1. So that is the reason here we can say 4 free electrons. Okay. So means variable valency here 4 it will come. Okay. Next, the second excited state. Because here one more paired electron is there, right? So that is why second excited state. This s electron will goes to the second one of this. Okay. So we will say that one. So s electron will come here. So this is coming here. So here 1, 2, 3, 1, 1, 1. Here again 1, 2, 3, 4, 5. Okay. So again this electron will come here. So already one came here in the second one. Okay. So this will come. This also will come. This will come here. That will come. So 1, 2, 3, 4, 5 and 6. So total how many electrons are there? Free electrons? 6 free electrons. So now sulfur can form variable valency 2, 4, 6 also it can form. So for example, see, I will tell you here SF2, SF4, SF6. This also we can say, especially for example, even chlorine when you are considering, like different atoms will be there. So based on this, we can say that sulfur non-metallic elements, phosphorus and sulfur alone having a variable valencies. Phosphorus 3 and 5, sulfur 2, 4 and 6. Okay. So if you remember this one, easily you can do even when you are framing a compounds, like how the compounds are involving in the bond formations. That and all is very easy for you. I hope everyone understood about this video. Thank you all.